and welcome to this video on the freebird application. We want to show here the main flow of the freebird application. In this case we've pre-configured an implementation of the FinRep reporting framework for a couple of reports, and we're going to show how to view this, and in another demonstration you can see how to do more advanced edits if you wish. So let's jump into it. How do we start the application? First we go to this website, github.com, eclipse efbt. Here you need to log into GitHub. GitHub is run by Microsoft, as a free account that's easy to sign up for. Once we've gone to this web page, we'll choose a branch. So if we choose master, we get the most stable release of the software. If you choose develop, you get the sort of up-to-date tested changes. And today we're going to use release 3.6 beta. And then once we've done this, we just click on code and then plus. And this starts up an environment for us in the cloud, so nothing is installed locally on your own machine. You don't need to ask for permissions or set up a lot of software. Now this takes about a minute to set up, so I'm going to pause the video. Okay, you see when it's ready, this pops up to say open in browser. We click open in browser. And that's the application started for us. This is the main screen. Today we're going to focus on the task workflow dashboard. And at the top we see the configuration. So what do we have here? The most important thing is this is a GitHub repository. This one I've already set up as a one-time task with the CSV files from the Bird website, and also any configuration, any executable files I create or that you create can be stored in this GitHub repository. You can make one by yourself. This one is already pre-configured. Next we have a test suite repository, and this stores some test data for some birds, so some example, and along with the test data there it has some expected results. We'll see that later. And also, because it's GitHub, we can choose a branch. We'll describe that later. We have 4 test cases available, and our bird content is based on the very latest Bird 6.6. So with our configuration done, the next thing we need to do is, before we run our main workflow, is our workflow setup. So the first step in there is to click retrieve artifacts. And this will go and get the artifacts from that GitHub repository about Bird and load it into this cloud environment. That's quite quick. Now the next thing is we choose which derived fields to enable or disable. So in Bird we have the concept of derived fields, where in the enriched input layer some fields are derived and they have a derivation rule. And here we've tested 2 derivation rules, and we say okay, you can choose which ones you want. Because here we're showing FinRep F04 and F05, then these are gross carrying amount is one that's used by those, so I'll choose gross carrying amount. Save and close. And we can also choose, we can also view and edit those derivation rules. So in the application, we translate from the Bird transformation rules in pseudocode into ones that we can execute in Python. So here's 2 that we've checked already, we call them production, but we can also look at the auto-generated ones. So for example, let's look at default status derived in the credit facility table, edit, and we'll see it shows the original algorithm from Bird in pseudocode, and then it shows the Python code that it generated from that. And here normally the Python code is perfect, but we should still edit it, we should still check it, edit it, and we can save any edits that we make. We can actually edit directly here, and we can save that, and if we do deploy, it will actually be added to our list of production fields and available next time. Okay, so let's go back to our workflow. Then we need to set up the database. We click Set Up Database, and behind the scenes it'll create a database with the tables of the bird enriched input layer, tables like instrument and party and instrument role, etc. This takes about 30 seconds. And we note that the bird enriched input layer is a superset of the input layer. It has all the columns of the input layer and some extra ones, which are derived fields. Okay, now in the freebird application we have the concept of joins. Joins in Bird, if you read the metadata manual, are always an implementation concern, how we join up the data. And so here, if we click here, we see in this IL definitions, this is where we have configured a set of joins. We create a join per product, and these, to be precise, are join hints, are a very high level, easy to understand view of what the join is. They don't go into technical details of inner, outer, left, upside down joins, whatever. So if we click on other loans, we'll see the definition for our other loans join. We'll see that it has 5 tables that need to be linked together: instrument, instrument role, party, instrument entity role assignment, and collateral. And we see these highlighted in the middle here when we click on this. The one in red with a star against it is what we call the main table, and we use this to drive the cardinality of the join. If we look at another product, let us say debt securities, we'll see the tables there are more security related. They're party, long security position, prudential portfolio assignment, security position, security exchange tradable derivative, etc. And when we click on that, we'll see that these are highlighted in the table here. This is a visual representation. We can also look at the text representation, which is a simple CSV file where we say other loans is instrument role, party, instrument entity role, etc. And this can be downloaded, and it can also be edited here. So this is the visual representation. So let's close that. Now that's our workflow has been set up, we're going to run the main workflow. The main workflow has 4 steps. 1, the creation of the SMCubes core metadata database. It takes a CSV metadata, creates a database behind the scenes with that in it. Then it's SMCubes transformation rules creation. Then from the SMCubes transformation rules we create the Python transformation rules. And the last step is a full execution against our test suite. Now, because we're in simple flow here, we're not going to be editing things between the steps and reviewing after every step. We just want to run step 1, 2, 3, 4 in order, and we can do this by choosing 4 here and run auto mode. And this is going to run steps 1 to 4 for us in order. This takes about 2 minutes, so I shall pause the video. Okay, that is completed. Now we can look at the review of each of these. As I mentioned before, we're not going, in the review we could go and edit and rerun steps, but this is a simple flow. Let's look at the review first of the SMCubes transformation rules. Most important thing here is the cube links visualizations. Now cube links are, we can consider as one of the main parts of the metadata of Bird. Let's look at the cube links for the FINIP FO501 report and the other loans join. So the other loans belong to the joins that we set up before. And we'll see here is saying for the output report, output layer, finip FO501. Where did we get each column from? So in the legend, we see we have a source cube, a source item, a target item, a target cube here. And we notice this is for the product, other loans, that join. So we see for that other loan, product, for the finip FO5, gross carrying amount came from gross carrying amount of instrument role. And we can imagine that if this was for debt securities or non-negotiable bonds, it might be from another input table. This is very important so we don't get confused where things actually come from. So let's make that a bit clearer. Let's look at another example. Non-negotiable bonds for FO5. This time we see gross carrying amount came from a security related table, long security position portfolio assignment. So, as mentioned, this is one of the critical parts of metadata lineage for Bird. Okay, let's go back to the workflow dashboard. Now, let's review the Python transformation rules created. This is a similar kind of screen to what we saw for the derivation rules. But here we've seen in our production code, what I've already checked and tested, we have a representation of the cube links and the joins for a report, like finite FO501. This top part is related to the cube links. It's a representation of all those lines we just saw in the cube links. We can also go and we've generated these files. We can edit one, and then when we're happy with it we can deploy it and it'll become one of these production files which will be available next time. So we edit. Again, top half is all related. You might recognize these things from our cube link lines. If we scroll to the bottom, we'll see, for example, this thing FO1 other loans, calc other loans. This is a Python code that represents our join. This is very important. We see this is auto-generated from our join configuration. So for other loans, we have instrument, instrument role, party, instrument entity role. So it's created like a template in Python for us to fill in. It's given some instructions to join up any reference tables that you need to join. And we're going to follow those instructions and test. Imagine we're happy with this, we'll save it. But we look at the one I already checked before. And then we can look at the join there. For other loans, for finite FO5. We have other ones, credit card debt, for example. Non-negotiable bonds. Here's the one for other loans. And here I've filled in this snippet of Python code to go and join up the instrument role table and the instrument entity role table, etc. in the required way. The other file we create here is called report cells. This is the other part of lineage in Bird. It represents what we call filters. Now we can see if we go to the Bird website. Oh, sorry. Bird website. If we were to look at the finip FO501 report, we were to look at other term loans, gross carrying amount, this cell 152589. See these filters, so accounting classification should be this, type instrument should be that, held for sale should be this. And that's what we're showing in this Python file. It's generated from that information of Bird. For each data point, it's saying these filters. So accounting classification should be in 2, instrument type product should be 2, institutional sector, held for sale indicator, etc. And this is generated with a high level of quality. You can edit and check it also. So this is our Python code for report allocation, these filters, also for joins and also for the cube links. 98% auto-generated, but you can edit, test, save your results, even share your results, so someone else doesn't need to do the same work a second time. So let's go back to the dashboard. Let's review our next step, which was full execution with test suite. Here it's run 4 tests. So it's basically taking in test data, describing the test, executed report cells, found the value and compared it to expected results. We see 2 passed and 2 failed. The ones that failed, it's saying for data point 152457, it was given an expected value of 11. It loaded in this test data for a loan and guarantee, and it found that the result was 0 and not 11 as expected. So it failed, and this could be, you could have hundreds of tests. And here ones have passed, we'll come back to this later, but the data point 152589, we just looked at it. The expected result was 83 million with this test data, and it passed. So this is automated testing framework. Now we get to the very cool stuff. If we go to freebird application, the home page again, and we go to a report viewer, and we find the report FinNet FO501, specifically for FinNet version 3. And here we see a report layout. If we click on this cell, which we were looking at before, it's going to go away and do the calculation. So the application has something called an orchestrator. It finds all the different Python snippets it needs to run for that cell, and it runs them right now against the test data. Actually, the test data for test number 4, which was the last one loaded in. We can also execute all cells. It can be a little bit slow. We have 2 versions of the orchestrator, one fast, one slow. The slower one records all the data lineage well, as we'll see shortly. So I'll pause the video while this runs. Okay, that's completed. Let's look again at this other term loan cell. We'll see something very cool indeed, which is we can view the data lineage, not the metadata lineage, but the data lineage. Let's click all here to show all lines. Let's tidy this up a bit with some drag in. It's important to realise that data lineage is really a function of the implementation, whereas metadata lineage is included by default in Bird. So what are we seeing here? Here's that data point, that report cell we looked at earlier of 83,491,250. And then here in light blue, this is the join for other loans. This was done using our high-level overview and then our technical implementation of the join, and joined up the data. Where does it get the data from? These 4 input tables from the enriched input layer. Here's their values, also for example the institutional sector of the party. So from these green tables of the input layer, enriched input layer, we're only showing the fields that are actually used to make this a navigable, easy to view diagram. We join up the data and then we apply our filters and we get this result here. So this shows the full data lineage. This is actually stored as a JSON file, so you can do other visualizations. You imagine this visualization might not be very good for 1 million transactions, for example. So that's the data lineage. We've gone from bird artifacts at the start all the way to this using test data. So I hope you found that interesting. Thank you for watching.